This is a total production. Alright, Chem Minions, Total here, coming at you from the Laundry Cave. So this second video for our Chapter 3 practice, we're going to focus on some specific functional groups, mainly alcohols, amines, amides, and alkyl halides. And so this kind of works in the practice of understanding if they're primary, secondary, or tertiary. All right, and so with alcohols and alkyl halides, it's pretty much just find the halide. So alcohols and halides are similar. So here we have an alkyl halide. And so to figure out if it's primary, secondary, or tertiary, you have to go to the carbon that it's connected to. And if you notice, this carbon is only connected to one other carbon. So this would be a primary halide. Right? For alcohols, it's a similar thing. Find the alcohol, right? Find the carbon it's connected to. And so you notice this carbon is connected to two other carbons. So this is a secondary alcohol, right? Looking at another alcohol here, OH, we have the alcohol. There's the carbon it's bound to. It's bound to 1, 2, 3 carbons. So this one would be a tertiary alcohol. Here, this alcohol, we have, so we have the alcohol. It's bound to this carbon specifically, and that carbon has one other carbon connection. So this is a primary alcohol. Right. Now we look at this structure. It has an alkyl halide, but then it also has an amide. Okay, so let's look at the halide first. So there's the chlorine, which makes it the halide. And if we look, the carbon it's bound to is bound to 2 other carbons. So this would be a secondary halide, alkyl halide. Now for the amide, we do this a little different. You have to look at the nitrogen. How many carbons are bound to it? So if you notice, this has a carbon here and a carbon there. So because it's bound to 2 carbons, right, this is a secondary amide. Okay. Now notice, of these amides, right, amide with a D, right, one of those carbons has to be a carbonyl carbon, the C double O. Alright, over here, the carbon that's bound to the nitrogen is not a C double O. Right? You don't see it directly there. So this is an amine, specifically a primary amine, right? And then this, even though it's not specified, I'm going to go ahead and tell you what it is. This is a ketone. So this carbonyl carbon has 2 carbon connections to it. So that's a ketone. Okay. So this and this is separate. These are 2 functional groups, while this is a part of one because the nitrogen is bound to the carbonyl carbon. All right. Here, that nitrogen does not have a bond with the carbonyl carbon. All right. Yet again, we see another nitrogen bound to a carbonyl carbon. So this is telling us we have an amide. Yet again. So what type of amide? Well, it's connected to 1, 2, 3 carbons. So this is a tertiary amide. Okay. We go down to the next one here. We don't see a C double O anywhere. We don't see a double bonded oxygen. So this is yet again an amine. And then remember, count the number of carbons that are bound to the nitrogen. You've got 1, 2. So this is a secondary amine. All right. Here we have a nitrogen, and this carbon, nor this carbon has a double bonded oxygen. So this is another amine. And as you notice, I said it's bound to 1, 2, 3 separate carbons. So that's a tertiary amine. Now you also will notice there is an iodide. Right? So we have another halide. And this, right, we got to go back to how we did it up here with like the chlorine. Because that's a halide, we have to go to the carbon that it's bound to, and we see that it's bound to 1, 2, 3 separate carbons. So we have a tertiary amine, but we also have a tertiary halide. Right? And then lastly, we see that we have another nitrogen. That nitrogen is bound to a double bonded carbon. So this is all one functional group as an amide. And you notice that nitrogen only has one carbon connection. And it is the carbonyl carbon, but we count it. So this is a primary amide. Alright, hopefully that helps with at least those three distinctions. Looking at our next question here, this one just wants us to identify all the different functional groups. So it's fair game for any of our lists. So of our like 4 slides of functional groups. So the one that stands out here is the one with the oxygen. So this is you have an oxygen that has a CH3 on one side and is bound to another carbon. So when you have an oxygen that's bound to 2 separate carbons, in this case, this would be called an ether. Okay, not to confuse it with an ester. All right, and so just to kind of help with that, I'm going to go ahead and jump down to this one. See, here you have a very similar scenario with the ether. This ether, so that ether had a single bonded carbon and a single bonded carbon. So does this oxygen, single bonded carbon, single bonded carbon. But this carbon also has the carbonyl. So when the carbonyl comes into play, we can't call it an ether, it's an ester. Okay? Alright, so don't mess those up. Those trip up students all the time, confusing ethers and esters, just like students confuse amides and amines all the time. Don't confuse them. Alright, let's go to our second one. Here we have an alcohol, and we know that that is a 1,2. That's a secondary alcohol. And then we saw this before. We have an isolated carbonyl where it's bound to 2 separate carbons. So this is a ketone. All right. Next we have over here, we have a carbon-carbon double bond. All right. So this is called an alkene. Right. Here we have a carbon-carbon triple bond. So this is called an alkyne with a Y. And then this, even though it has carbon-carbon double bonds, right, because it's this 6-membered ring and you have this alternating double, single, double, single, double, single stuff going on, this is a very special kind of structure. So we don't call this alkene. We call this arene. An arene because it's aromatic. It's a ring that's aromatic, and anyway, we call it an arene. All right. Next over here, we got 2 separate carbonyls. This carbonyl has a carbon, so this carbonyl is bound to both a carbon and a hydrogen. So this isn't a ketone. This, because that hydrogen's there too, this is called an aldehyde. Okay. Now with this carbonyl, it's got a carbon, which isn't necessarily important, but this OH is very distinctive. So all of this counts together as not an ester, okay, but a carboxylic acid, okay, because it's an OH. See here, this ester, that O is bound to another carbon, not a hydrogen, okay, so these little subtleties are going to trip you up. We have yet again another arene, and then here it's a bunch of fluorines, right? So this is more halide stuff. So I just call that a halide or a fluoride if you want to be specific, right? Here we have a chlorine, so it's another halide. And remember, you look at the carbon that's bound to it; it's got 1, 2 carbon connections. So this is a secondary halide, okay. And then over here you have the nitrogen. It's bound to 1 carbon, but that carbon is a double bonded oxygen on it. So, right, all of that is 1 as an amide. Now remember, we classified that as only 1 carbon connection on that nitrogen makes it a primary amide. All right. So hopefully this kind of helps going through the practice. See you later. Stay weird.